Chapter 7.3 covers similar triangles. In a previous chapter, we covered congruent triangles and it had shortcuts to prove that they were congruent. In this chapter, we also have shortcuts to prove that two triangles are similar. Remember, for two triangles to be similar, corresponding angles had to be congruent and corresponding sides had to be in the same proportion. One of the shortcuts that we're going to look at is AA, proving that two sets of corresponding angles are congruent. Of course, then we know that the third angle has to be congruent. That proves that they're similar. So in the first problem A, we're determining whether the triangles are similar. So first thing I'm going to do is figure out what the measure of angle A is. And if I add 42 and 58, which is angle B and angle C, I get 100 degrees, and 180 minus 100 leaves 80 degrees for angle A. So that shows me that A and E are congruent, and so are B and D. So since angle A is congruent to angle E, and angle B is congruent to angle D, by AA, I know that the two triangles are similar. Again, I have to be really careful what order I put them in. So ABC is similar to triangle. A lines up with E, D, F. In problem B, we're determining again whether the triangles are similar. We have two parallel lines, so I know for sure that Q has to be congruent to N. So angle Q is congruent to angle N by alternate interior angles. And I know that these vertical angles also have to be congruent. So I have two sets of angles congruent. So again, by AA, I know that triangle QXP is similar to triangle NXM. This problem A is very similar to how we did problem A before. So if I add 42 and 52, I have 94. Subtract that from 180, and I have that this top angle here is 86. So I have angle A is congruent to angle G, and angle B is congruent to angle F. So I have triangle ABC congruent to triangle GFH, because I know that A has to go with G. So that rules the first one out. A goes with G on this one, B goes with F, and H goes with H, so it'd be B. On this one again, basically because we have parallel lines, we know that W and Y are congruent. We know that these two angles here are congruent because of vertical angles, and also by alternate interior angles, we know Z and X are congruent. So again, this one is by AA. We just have to make sure that we have W and Y lined up, V and V, and X and Z. So it'd be A. The next shortcut we have is side, side, side. If I can show that all the sides have the same proportion, then they are similar. And the next one is very similar to what we have for congruence, side, angle, side. As long as I can show that two sides are proportional and the angle that's included between the two is congruent, we have that they're similar. So looking at the first problem here, we're determining whether they're similar or not and write a similarity statement. So my first idea is to do AC over CE. So I have 6 over 5. Does that equal AB over DE? So that'd be 9 over 6, and that definitely does not equal each other. So let's try something else. Let's try AC over CD and see if that works. So 6 over 4, does that equal 9 over 6? And does that equal 15 oh, excuse me, it's not 15, it's 7.5 over 4. Well, 6 over 4 reduces to 3 over 2. 9 over 6 also reduces to 3 over 2. And 7.5, I can basically look at 75 over 40, and does that work? Excuse me, it's not going to be 7, I messed this one up, it's 7.5 over 5. So this one over this one. That's 75 over 50, and that does definitely reduce to 3 over 2. So this be yes, by side, 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 and it would be triangle ACB is similar to triangle DCE. On this one, we're going to look at the small triangle and then the larger triangle here. So this would be MRS. We know that angle M is congruent to angle M because that's by reflexive. So angle M is congruent to angle M, and that was the reflexive property. This whole side, if I did 10 plus 15, this whole side would be 25. 12 plus 18, this whole side would be 30. So is 10 over 25, does that equal 12 over 30? This would be 2/5. 6 would go in here 2/5, so that would work. So it's yes by side, angle, side. So triangle MNP is similar to triangle MRS. Here, let's try this one again. If I do PR over RS, so 4 over 12, does that equal 2 over 6? And yes, it does. We also know that angle R is congruent to angle R. So by side, angle, side, we have a congruency. So if I look at this, angle P has to line up with angle S, angle T with angle Q, and R with angle R. And it'd be by side, angle, side. In this one, we know that angle A is congruent to angle A if we broke these two triangles apart, the smaller one and the larger one. This whole side is 15. This whole side is 13.5. So we want to know, is 9 over 10 equal to 13.5 over 15? Well, this is 0.9 and this is 0.9 if we put it in our calculator, so it's true. So we have side, angle, side again. Angle A has to correspond with angle A, angle E with angle C, and angle F with angle B. So it would be this one here, A. In triangle RST and triangle XYZ, we are told that RS over XY is 2/3. Which of the following would be sufficient to prove that the triangles are similar? Just taking one more set of sides is not enough. Giving us just one angle is not enough. So we'd have to have all three of them in the same proportion. In this one, we want to know what is sufficient. So we know that these two angles here, so angle C and angle C, or ACB and DCE, have to be congruent by vertical angles. So we need to know that the corresponding sides, the sides on either one of them are congruent, have the same proportion. So that would give us this one. This is the only thing we have. AC over DC, so these two, are in proportion to these two right here. So that would give us side angle side. The properties of similarity, where we have the transitive, symmetric, and reflexive all are all the same for similar triangles. So this one, even though it hasn't told you that they're similar, they are similar. We're being told that, and we can easily prove that they're similar by angle, because this angle here has to be congruent to this angle here. Angle Q has to be congruent to this angle Q because of vertical angles. So basically we know that triangle UQT is similar to triangle SQR. So setting this up, we know that RS, which is 4 over UT, so 4 over 10, has to be TQ and QR. So TQ is, we're going to do the smaller one on top, so x plus 3 over 2x plus 10. So this 4 belongs to the same one as x plus 3, that's why they're both on the same side. Cross multiply, so we have 4 times 2x plus 10 equals 10 times x plus 3. 8x plus 40 equals 10x plus 30. So 2x equals 10 and x equals 5. They wanted us to find RQ and QT. So RQ, we're going to plug that in. So 5 plus 3 gives us 8. And with QT, we have 2 times 5 plus 10 will give us 20. Again, we know these triangles are similar by angle because we have 2 parallel lines. So we know that this is congruent to this. So triangle ACB is similar to triangle ECD. So setting this up, we know for sure that 38.5 over 11 has to equal AC and CE. So 3x plus 8 over x plus 2. So 38.5 times x plus 2 equals 11 times 3x plus 8, which gives us 38.5x plus 77 equals 33x plus 88, which will give us 5.5x equals 11. So x equals 2. Plugging it back into the side we want, which is AC, we have 3 times 11, 3 times 2 plus 8, which would give us 14. Here's a list of the similarity theorems that we've already looked at. We'll be looking at some more in the next lesson, but we do have AA, SSS, and SAS. And this concludes lesson 7.3.